Our technology solution is ready to tackle climate kerfuffle head-on and put concrete measures in place. We totally nailed it. The Violon apparatus can capture a large amount of carbon dioxide from flue gas globally, especially in hard-to-abate sectors. Our modular design CCU is a key and simple solution for converting carbon dioxide into bicarbonate ions in the solvent. Photosynthetic microalgae can utilize abundant nutrients to effectively fixate large amounts of CO2 in seawater or water. 90% of total photosynthesis is carried out by aquatic plants, chiefly algae, 80% in oceans, and 10% in fresh water. Only 10% of total photosynthesis is performed by land plants. In water, microalgae have the ability to fix carbon dioxide 50 to 300 times more than other terrestrial plants. How to effectively harness microalgae for the efficient fixation of a large amount of carbon dioxide? The solubility of carbon dioxide in water plays a crucial role in restoring the balanced carbon cycle of the planet. The atmospheric concentration of carbon dioxide is about 420 ppm. The concentration of CO2 in stack emissions is approximately 100,000 ppm. Our CCU technology captures carbon more energy efficiently from sources that are over 250 times higher than those typically addressed by DAC. Our technology solution is highly efficient, as the apparatus directly captures carbon dioxide from stack emissions. Violon's Bio-CCU solution technology for accelerating carbon cycle conversion. The technology readiness levels of the apparatus range from TRL-8 to TRL-9. The capture capacity of the apparatus ranges from 2,000 tons to 100,000 tons of CO2 per year. The high-efficiency apparatus for capturing CO2 is energy efficient and can be deployed quickly. Our patented CCU technology can effectively address the challenge of enhancing the solubility of carbon dioxide in aqueous solutions. Using biomass to fixate carbon dioxide and accelerate the fast carbon cycle. Our solvent-based CO2 scrubbing processes do not require heating or pressurization. The system apparatus achieves a starting net carbon efficiency of 95%. The solution distinguishes itself from other CCU or CCUS methods by significantly reducing energy consumption. Our system apparatus captures digital information while adhering to the core carbon principle of the Integrity Council. It can be measured, reported, and verified by an independent third party. In the voluntary carbon market, Violon is committed to maintaining transparency, avoiding greenwashing practices, and preventing double counting of carbon credits. To achieve net zero carbon emissions by 2050, it is crucial that we maximize the utilization of every available tool to address the imbalances in the carbon cycle. It is crucial for hard-to-abate sectors to prioritize the gradual reduction of carbon emissions while maintaining integrity in the process. Numerous tools and methodologies have been developed globally to reduce carbon emissions. The atmospheric concentration of carbon dioxide is increasing at a rate of approximately 2 to 3 ppm per year. What actions can we take to prevent the carbon cycle system from reaching a tipping point? Greenwashing, by promoting false solutions to the climate crisis, distracts from and postpones concrete and credible action. Transitioning to low-carbon manufacturing technologies and processes presents a challenge from a cost perspective, especially when profit margins are tight. Operating carbon capture and storage systems indeed requires a huge amount of energy. CCS actually releases more CO2 into the atmosphere than it has removed. The injection of CO2 could potentially cause earthquakes. Not only does it destroy the natural carbon cycle, but can also lead to natural disasters. There are also additional unpredictable risks associated with the storage of carbon. Violon development technology consists of 3 components. First, carbon capture technology. Violon has been granted worldwide patents. Our apparatus is technically feasible for implementation in the steel industry located in Changzhou, Jiangsu. using flue gas in the steel industry. The concentration of carbon dioxide in the flue gas is about 100,000 ppm. The initial spray tower reduces the temperature by utilizing water, effectively removing dust through washing. The spray tower has the capability to remove up to 95% of PM2.5 and PM1.0 particulate matter. In the second phase, the waste gas enters the patented alkaline solvent washing tower. Carbon dioxide is washed in reflux with sodium hydroxide in 3 alkaline washing towers, gradually reducing the concentration of sodium hydroxide. After the conversion process, the concentration of carbon dioxide is reduced to several thousand ppm. Approximately 90% of the carbon dioxide is converted into liquid bicarbonate. Alternatively, it can be formed into solid bicarbonate powder. Second, microalgae fixation. The patented solvent facilitates the conversion of a large amount of carbon dioxide into bicarbonate ions when dissolved in water. The availability of bicarbonate ions is crucial for microalgae to obtain a carbon source in water or seawater. Photosynthetic microalgae can fix carbon dioxide at a rapid rate. The process can yield abundant feed from microalgae powder. Our modular microalgae cultivation bioreactor has been improved and tested. The bioreactor's ideal fluid mechanics promotes circular and energy-efficient flow, facilitating optimal microalgae growth. Microalgae cultivation can achieve net zero carbon emissions by utilizing solar panels. Our bioreactor emphasizes the importance of high microalgae biomass densities in cultivation. Microalgae grow faster than crops and livestock, producing more protein in less time and using fewer resources and less land. Instead of using fresh water, we employ seawater for culturing microalgae. Our solar-powered modular greenhouse enables successful microalgae cultivation in challenging environments like deserts or saline and alkaline land. By utilizing the wasteland, we can effectively capture and utilize carbon dioxide, thereby enhancing carbon sinks. Third, microalgae for fixation and applications in aquaculture. We have been working hard and studying the technologies for several years. We have started collaborating on research projects with famous universities worldwide. Microalgae-based products are vital for the future of food and animal feed industries. The crude protein content of microalgae powder varies between 55% and 60%. Microalgae have developed to be efficient in resource utilization and have proven to be a viable source of nutritious biomass. Microalgae provide a sustainable source of omega-3 fatty acids and high protein content, which have proven to be vital for the aquaculture industry. As fish meal production declines annually, microalgae powder can be an alternative to replace part of it. Microalgae could be a sustainable feed option for livestock, reducing the need for land to grow animal feed crops. The feed of microalgae powder can replace a portion of other feed ingredients, such as soybean, wheat, and corn. This solution can tackle various food production challenges linked to climate change. Growing microalgae can help reduce the requirement for reclaiming tropical rainforests to cultivate forage crops. Our carbon dioxide removal method can preserve the carbon sink provided by forests while maintaining their original biodiversity. Microalgae powder has a wide range of commercial applications. The circular carbon economy can be established through such initiatives. Violon's technology solution has the potential to contribute to achieving 4 out of the 17 Sustainable Development Goals. SDG 13, Climate Action. During the move towards net zero emissions, our technology solution provides a valuable tool for tackling emissions in challenging sectors and restoring biodiversity. SDG 14, Life Below Water. By imitating nature, our solution can recycle and utilize carbon emissions within the biosphere. SDG 15, Life on Land. Using microalgae for feeds or food can reduce the amount of land needed to feed the growing population. SDG 2, Zero Hunger. Microalgae could potentially play a pivotal role in ensuring global food security in the future. Violon's Bio-CCU solution technology for accelerating carbon cycle conversion and microalgal carbon dioxide fixation and biomass utilization technology, both carbon capture and utilization and carbon dioxide removal, combine technology-based solutions and nature-based solutions. Only by combining the two methodologies can we effectively tackle large amounts of carbon and achieve a net efficiency of 95%. The technology solution can be quickly deployed in heavy industry. By 2026, the hard-to-abate sectors will be obligated to pay the rising carbon tax and the carbon border adjustment mechanism. Violon's patented CCU technology is highly technical. The budget costs can be managed and controlled. Modular apparatus design for hard-to-abate sectors. Violon has been actively developing next-generation CCU technology. The supply chain of microalgae cultivation and aquaculture can generate additional green jobs. Heavy industry plays a crucial role in the transition to a net-zero economy with both potential risks and rewards. Implementing a practical solution to reduce carbon dioxide emissions in challenging sectors can bring significant economic co-benefits. Our apparatus can obtain third-party certification and apply the CCP label in the high-integrity voluntary carbon market. Violon's technology solution has the potential to create a climate-positive future for hard-to-abate sectors. We must act urgently on climate to secure a livable future for all.